Hello, everyone. I'm Sinisa, and it's nice to be here at BOSC after a while. Up until 2018, I used to work on the common workflow language and like a lot of executors and stuff. And for the last 6 years at Memorial Sloan Kettering Center, I kind of work more like on the infrastructure. How do we run the pipelines and automate those runs? So that's why we built Voyager. That's a platform with automate the execution of computational pipelines. It takes data from our data sources, run the necessary pipelines, and deliver results directly to our analysts. And the Voyager simplifies how we orchestrate and monitor pipelines across different compute environments. Now we can support like Slurm and LSF, and we can support running both CWL and Nextflow pipelines. So let me take you to the life cycle of the data through the Voyager. So when the data is sequenced, like it's imported into Voyager, where Voyager validates the received data, choose the right pipeline based on the metadata, construct the pipeline inputs, run the pipeline, and deliver the results. And all this happens without any of our manual intervention, while we keep observability and reproducibility built in. So I'm going to lead you through the architecture of Voyager. So the data importer is responsible for collecting and receiving data from external sources. It validates the data and registers it into our database. The file manager is how we interact with the data. It allows us to query files by the file paths or any metadata which is associated with those files. It is used by the operators who basically select the data which is for processing, or it can be used by the users to like review the previously executed pipelines. The operators are core of our automation system. Each operator handles specific pipeline and transform the data using the file manager into the input format expected by that pipeline. And this format is abstracted. So we use basically the CWL input schema for the CWL, but we use the NF core convention for the Nextflow pipelines so we can, in a unified way, construct those inputs. And once the pipeline and its inputs are defined, a run is created. The runner then takes the run and submits it to the appropriate job scheduler, LSF or Slurm. The runner uses Toil for the CWL and the Nextflow for the Nextflow pipelines. And we use the built-in function from the Toil and from the Nextflow to basically handle the errors and retries in this case, so we can prevent any failures. When the runs is completed, the outputs are stored back in their file manager, and from there they can be reviewed or reused by some additional operator for additional analysis. And because each run is saved in our database, we basically are able to rerun any analysis at any time on any of the supported schedulers. So this architecture had like a couple of problems. So the biggest one, that operators were deeply embedded in our Voyager core, and that made them hard to update and replace. It was also pretty hard to test because you need to set up the whole Voyager in order to run those tests. And that code was not really reusable between the operators. So with more groups within our institution, which was willing to use the Voyager automation, we needed to kind of empower them so they can integrate their own pipelines and operators into the Voyager. So that's how the Voyager SDK became as an idea. So we wanted to decouple the operators. They had to become independent from the Voyager's core. We did that by building like the CLI tools and SDK library, which makes operator creation fast and intuitive. And the also important thing was to build like a dynamic operator management system. So when somebody builds their operator locally and test it locally, it can be registered within the Voyager and run into production. So running the pipelines at scale is a common challenge, like within many institutions. And like there are also like there will always be multiple pipeline standards: CWL, Nextflow, SnakeMake, and so on. And like all the institutions use diverse compute environments, local and cloud. So we designed the Voyager to be flexible, support multiple standards as scheduler, and like enable scalable, reproducible, and maintainable automation. So here are some of the links to Voyager. We're like one of their short-term goals is to improve more like a documentation, but you can always reach out if you find any of things useful. We can reach us out. Thank you.